Today we are going to cover section 10.4, use square roots to solve quadratic equations. Example 1, solve quadratic equations. Solve the equation 2x squared equals 8. Solve 2x squared equals 8. So one way we can do this is to, just to review a little bit, is to get everything over to one side and make it all equal to 0 by subtracting 8 from each side. That's 2x squared minus 8 equals 0. And now let's factor the greatest common factor, which is 2. And then 2 times x squared is 2x squared. 2 times negative 4 is negative 8 equals 0. We have a difference of squares, a square subtracted from another square. So make 2 sets of parentheses to factor it. The square root of x squared is x, so put that at the beginning of each of the parentheses. And the square root of positive 4 is 2. Put plus in one and minus in the other because it's a difference of squares. Now we have 3 quantities that multiply together equals 0, so one of those quantities must be 0. If x plus 2 equals 0, which is a possibility because 2 times 0 times x minus 2 is 0, since anything times 0 is 0, then in that case, subtract 2 from each side, we get x equals negative 2. If x minus 2 is the quantity that equals 0, then add 2 to both sides. You get x equals 2. And obviously 2, the other quantity there, does not equal 0. So we have x equals negative 2 or x equals 2. But now we're going to look at a different way of solving using square roots. So we have 2x squared equals 8. With this method, you want to isolate the variable squared. So divide each side by 2. The 2's cancel out. So we have x squared equals 4. Now that the variable squared is isolated, take the square root of each side. Square rooting cancels out squaring, so we're left with x. And we need plus or minus 2 because the answer is x equals positive 2 and x equals negative 2, because negative 2 multiplied by itself also equals 4, since a negative times a negative is positive. So that's another way of writing the answer, and that means x equals positive 2 or negative 2. And you can check your answer by substituting in positive 2 for x in the original equation and seeing if you get a true equation, and then you can do the same thing with negative 2. M squared minus 18 equals negative 18. Let's add 18 at both sides. So now we get m squared equals 0. The variable squared has been isolated, so take the square root of each side. Square rooting cancels out the square. We're left with m, and the square root of 0 is 0, since 0 multiplied by itself is 0. So we get m equals 0. And you can check your answer by substituting in 0 for m in the original equation and seeing if you get the true equation, which you would. Now let's look at part C. We've got solve b squared plus 12 equals -5, or sorry, equals 5. Subtract 12 from each side to isolate the variable squared. That's going to give us b squared equals -7. And take the square root of each side. Square root of b squared is b. There is no solution because it's impossible to take the square root of a negative number because no number multiplied by itself equals a negative number. A negative times a negative would be positive, not negative. Now let's look at example 2. Take square roots of a fraction. Solve 4z squared equals 9. Example 2. All right. Well, let's review the factoring method first. Let's get everything over to one side and make it all equal to 0. So that's 4z squared minus 9 equals 0. We have a difference of squares, a square being subtracted from another square. So let's make 2 sets of parentheses. The square root of 4z squared is 2z. Since 2z multiplied by itself, 2z times 2z is 4z squared. The square root of positive 9 is 3. So put 3 at the end of each of the parentheses. And then put plus in one and minus in the other, since this is a difference of squares. You can check to see if it was factored correctly by using FOIL and combining the like terms. You would see that outer and inner cancel out, and you'd be left with the previous step, 4z squared minus 9, so this is factored correctly. We have 2 quantities multiplied together equals 0, so one of those quantities must be 0. If 2z plus 3 equals 0, which is possible because 0 times 2z minus 3 is 0, since anything times 0 is 0. Then isolating the z, subtract 3 from each side. That's 2z equals -3. Divide each side by 2. We get z equals -3 over 2. If 2z minus 3 equals 0, then isolate z by adding 3 to each side to get 2z equals 3. Divide each side by 2. We get z equals 3 over 2, or 1.5. Okay, so there's our 2 solutions. Z equals -3 over 2, and z equals +3 over 2, or +1.5. All right, so we reviewed the old method. Now let's look at the square root method for the 4z squared equals 9. So in this method, we isolate the variable squared by dividing each side by 4. 4's cancel out. We have z squared equals 9 over 4. Now that the variable squared has been isolated, square root each side. Square rooting cancels out squaring, so we're left with z. And then the square root of a fraction is equal to the square root of the numerator over the square root of the denominator. The square root of 9 is 3. The square root of 4 is 2. And it makes sense that square root of 9 over 4 is 3 over 2 because 3 over 2 multiplied by itself, 3 over 2 times 3 over 2 is 9 over 4. And we need plus or minus. Always, anytime you take the square root of both sides of an equation, put plus or minus on the opposite side of the variable, because z equals +3 over 2 and -3 over 2, because -3 over 2 multiplied by itself is also 9 over 4, because a negative times a negative is positive. Positive 9 over 4. So that's another way of writing the answer. Z equals +3 over 2 or -3 over 2. And you can check your answer by substituting in +3 over 2 in for z in the original equation and seeing if you get a true equation, which you would. and then doing the same thing for negative 3 over 2. Now let's look at example 3. Approximate solutions of a quadratic equation. Example 3. Solve 3x squared minus 11 equals 7. Solve 3x squared minus 11 equals 7. Round the solutions to the nearest hundredth. Round to the nearest hundredth. Okay, so let's use the square root method. So let's isolate the variable squared by adding 11 to both sides. We get 3x squared equals 18. Divide each side by 3. That gives us x squared equals 6. Take the square root of each side. Square root of x squared is x. And that's plus, so we have plus or minus square root of 6. Let's use a calculator to find the square root of 6. Okay, so for this TI-83 that I have, which should be similar to a TI-84, which most of you probably have, use the second button and then hit the x squared button, and that's going to give you the yellow square root sign above the x squared button. And then put in 6, close the parentheses, hit enter. The square root of 6 rounded to the nearest hundredth, or the second decimal place, is 2.45. So x equals plus or minus 2.45. So x equals positive 2.5 or negative 2.45. And then you can check your answer by substituting in positive 2.45 in for x in the original equation. And if the equation is approximately true, then you know you probably have the correct answer. And then do the same thing for negative 2.45. Now let's go to example 4. Example 4. Turn the page. Okay, solve a quadratic equation. Solve 6x minus 4 squared. 6 times x minus 4 in parentheses squared equals 42. Round to the nearest hundredth. Round to the nearest hundredth, or the second decimal place. So let's isolate the parentheses squared by dividing each side by 6. The 6's cancel out. Now we have x minus 4 in parentheses squared equals 7. And the parentheses squared has been isolated to get rid of the squared, square root each side. Now we have x minus 4 equals plus or minus square root of 7. Add 4 to both sides. We get x equals plus or minus square root of 7 plus 4. Or just to make it look a little bit nicer, let's rearrange the terms and make it 4 plus or minus square root of 7. And let's use a calculator and round it to the nearest hundredth. So first let's find 4 plus square root of 7. Let's see what that's approximately equal to. So 4 plus, and then second button, x squared button to get the square root symbol. And then 7, close parentheses. We get 6.65 when rounded to the nearest hundredth. Now let's find x equals 4 minus square root of 7. So 4 minus second button, x squared button to get the square root symbol above the x squared button. 7, close the parentheses. That's 1.35 when rounding to the nearest hundredth or the second decimal place. So our solution is x is approximately equal to 1.35 or 6.65. And you can check your answer by substituting in both values in for x in the original equation, and if you get an equation that's approximately true, then you know you probably have the correct answer. Example 5. It's a word problem. During an ice hockey game, a remote-controlled blimp flies above the crowd and drops a numbered table tennis ball. The number on the ball corresponds to a prize. Use the information in the diagram to find the amount of time that the ball is in the air. All right, so here is the diagram. You have a blimp. You're going to get to witness my amazing drawing skills. And here's the ground level or ice level. You have a person up here in the stands. There's one of the people in the stands, the person who's going to catch the tennis ball. All right, so the ball is dropping to that person. Okay, so the blimp is 45 feet above the ice. And the person who catches the table tennis ball, the ping pong ball, is 17 feet above the ice. Let's figure out how much time the ball is in the air, going from the blimp to the person who catches it. So we need to use one of the most basic equations in physics. The distance that an object travels is equal to 1/2 times the average acceleration times the amount of time the ball is traveling squared, plus v, the initial or beginning velocity, times the amount of time the object is traveling, plus s, the initial position, the beginning position of the object. Okay, so the distance, the distance the object travels is equal to the height. Let's replace distance with height. And 1/2. The acceleration, since this object is falling, it's experiencing the acceleration due to gravity, which is negative 32 feet per second squared, which means every second that the object falls, its velocity increases by 32 feet per second, and it's negative acceleration because gravity's pulling downwards, which is a negative direction. Every second that an object rises, its velocity would decrease by 32 feet per second. All right, and then t squared and the beginning velocity is 0, because at the moment the ball is dropped, it's not going at any speed. And then the initial position of the ball is 45 feet above the ground. All right, let's simplify that. A positive times a negative is negative. 1/2 of 32 is 16. 0t is 0. And plus 45. Let's substitute in 17 for the height, because the ball stops when the person 17 feet above the ice catches it. Let's subtract 45 from each side. Oh, I forgot the t squared. Now let's isolate the variable squared by subtracting 45 from each side. We get negative 28 equals negative 16t squared. Divide each side by negative 16. The negatives cancel out. And then 28 and 16 can be simplified by dividing top and bottom by 4 to get 7 over 4 equals t squared. The variable squared has been isolated, so square root each side. Square root of t squared is t. And then plus or minus. So square root of a fraction is equal to the square root of the numerator over the square root of the denominator. Square root of 7, we can't simplify that. But square root of 4 is 2. Okay, it's too bad I'm running out of room there. Well, let's find, first of all, t equals positive square root of 7 over 2. Yeah, that's all we need, because it cannot be t equals negative square root of 7 over 2, because then you would have a negative time, which doesn't make sense. So it must be t equals positive square root of 7 over 2. So let's put that in the calculator. So hit the second button and then the x squared button to get the square root sign above the x squared button, and then 7, and then division sign 2. That's going to give us rounded to the nearest hundredth or the second decimal place, 1.32. 1.32 seconds must be the unit, because seconds was the only time unit used in the problem for the values we substituted into the equation. And all the distance units were kept the same, feet. So it must be 1.32 seconds that it takes for the ball to drop from the blimp to the person 17 feet above the ice. And thus concludes section 10.4, use square roots to solve quadratic equations. Thank you.